Hello guys, in this video we will be learning how to solve a 2D test. So we have actually three method that we can use to solve a test. So first is method of joint, and another is method of section, and then we can method of section, then we can solve using Maxwell diagram. This Maxwell diagram. So this is also known as graphical approach. So we will be learning only how to solve using method of joints in this video. So before starting, I would like to tell you that this is how we define tension in a member force, and this is how we define compression in a member force. And we will assume before and we will assume that each and every member is in tension. So the force will be like this in each and every member before starting the analysis. So okay, so now we need to find AY and EY. We know this is pin support, so this will be AY and AX, and this is a roller support, this will be only EY. So we know AX will be equal to 0 as sigma Fx is 0, and there is no horizontal force in this stress. So we can find AY easily. You just need to see that this is 4 part, 1 2 3 and 4. So take 360 into this part, like the right one part, 1 by 4 plus 270 into 2 by 4 plus 180 into 3 by 4. Similarly for EY, this will be 360 into like far away part, 3 by 4 plus 270 into 2 by 4 plus 180 into 1 by 4. So after solving this, we get this as 360 kilonewton, and we have to solve E, and we get ES 450 kilonewton. So now after this, we know that at joint A we have a force acting as 360 kilonewton in upward direction, and then one force member will be this and another will be this. So how we can define this? We know that this we are considering this in tension. So see that we are cutting it from here. So this is this one. This is how this will be marked. So we can, the force in this member will be force in A, and this upper joint H. So force in A H, and in this one will be force in AB. If we will, so this will be equal to force in AB, force in AH, and we have a 360 kilonewton acting upward. Now we need to find this angle to further solve this. So we can easily find this. Theta is equal to tan inverse of 6.4 divided by 4.8, which comes out to be, let me calculate, 6.8 divided by 4.8, which comes out to be 54.78 degree. So now we know that theta is 54.78 degree. So either you can take component of this as FAH cos theta and sin theta, or you can use triangle law. We will be using a triangle law. So this will be FAB, this is 360, and now we will be changing the direction of this force. So it was tensile before, but now it's compressive. So we know this angle is 54.778, and this is 90. So we have 90 plus 54.78, and 180 minus of this will be, so this angle is 35.21. So after solving, we will be using sine law. We know sine law. What is sine law? So force in AB divided by sine of 35.21 is equal to force in AH divide by sine of 90, which is will be equal to 1, and then force in, then we have 360 divided by sine of 54.78. So we can solve this and then find the value of 54.7. Then we can find the value. So this whole value comes out to be 440.66. Then force in AH will be 440.66, and this is compressive. And force in AB is equal to 440.66 into sine of 35.21, and this is tensile. So what I would suggest you to make a truss like this, same truss, and then we know this is 360, this, 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 and this. So this will be force acting here. So now we know that this force is compressive, so you can mark this as compressive force, and then write the value also, which is coming out to be 440.66, and then we know this is tensile, and then we can also mark the value here as So now we have to jump to a from here we know that we can jump to either joint H or joint B, but if we will go to joint H, we will have three unknown member, 1 2 3, and if we will go to joint B, we will have only two unknown member, this one and this one. So we will be going at joint B. We have this force acting as 270. This will comes out to be 270 approx, I guess. And then we have one force acting as 180. Then we know that we have to consider these forces in tensile, so this is how the arrows of forces will be. So we have F in BH and then F in BC. So we can see that F in BH is equal to 180 and F in BC is equal to 270, both tensile. So we can mark like them. This is F in BH, F in BC will be 270 and F in BH will be 180. Now we can solve joint H easily. So at joint H, what we have is one force acting. Let me change the color. So we have 180, then this is 450, and then this is, we know that we were taking tensile force, so this will be force in HG, and this will be force in HC. So what we can do is simplify this. This is 180. We know this angle theta. This is force in HG, and we can find this angle. This one is theta 1, this one is theta 2. So we know this theta 1 is equal to 53.10, and we can find theta 2 easily with the given information. So then it will be equal to F in HG plus F in HC cos of theta 2 plus of 450 cos of theta 1, and then F in HC sine of theta 2, this will be 180 plus 450 into sine of theta 1. So first we will be solving the sigma Fy is equal to 0, which will be Fc sine theta 2 is equal to 180 plus of 450 sine theta 1. We can find the value of Fhc from here. Then we can put in sigma Fx is equal to 0. Then we can find the value of F in Hg. So after the complete analysis, we will be getting this force and this force. Now we can either choose this. Now we can either choose this one, this joint, or this one. If we will choose this, we will have 1 2 3 unknown. If we will choose this, we will have only 2 unknown. So we will be choosing joint G. Then after solving this, we will be knowing this and this. Then we can solve this joint. using this approach. So then we can like this we can solve the whole test using the method of joints, which is very easy. Thank you.